Welcome everybody to your final video of Unit 4, Topic 1. Today we are going to be simplifying radical expressions again. We just have a couple extra and additional examples we wanted to show you today. So to start off, I wanted to talk to you about an awesome, and by awesome I mean really awesome math fact. Did you know that the square root symbol and squaring a number are opposite operations? Just like adding and subtracting are opposite operations, multiplying and dividing are opposite operations, taking the square root of a number and squaring a number also are opposite operations. So here's what that means. If you're going to be asked a question something like the square root of 5 squared, okay? So if we didn't have this talk before, maybe the first thing you would do was to take 5 squared. 5 squared is 25. And the square root of 25 equals 5. Whoa. Well, here's what I noticed. Because the square root and the square are opposite operations, they cancel each other out. So all that you're left with is just that number on the inside, the base. So we're going to use that awesome math fact to simplify this expression. The square root of 3 squared times this 5 to the third power. So, bringing it back to what we talked about in the last video and simplifying radicals. I know if there's a multiply in between two things inside a square root, I can give each one of those things their own symbol. So that's the first thing that I'm going to do here. I'm just going to break apart that multiply and give each part on the inside their own symbol. And the reason that's helpful is because now I can simplify a little bit more. I can take the square root of 3 squared and know that the square root and squares are opposite, so these are going to cancel out. What am I left with? I'm left with a 3. Well, this other one, I'm not quite so lucky, because unfortunately, a square root and a third power are not opposite, so I cannot just automatically cross these out. But what I can do is I can know my exponent rules a little bit here, and I know that 5 to the third power means 5 times 5 times 5. And so since I know I want the exponent of 2 to cross out and cancel out my radical sign, I'm just going to rewrite this using 2 of the 5s. So I'm going to take 5 and make it to the second power. And then I can't forget about this other 5 over here. And I'm going to tag that along as well. So using the same idea and the same rules we used at the very beginning, I'm going to split up this radical sign between the multiply. So I'm going to have the square root of 5 squared times the square root of 5, giving them each their own symbol. The 3 is going to hang out in front. And what's awesome is now I have something that cancels out. I have a square root and a square, so those can be gone. They're crossed out. What's left is just that base, so a 5. So I have a 3, I have a 5, and I have a square root of 5 left. Now, can I simplify square root of 5? If I go to my calculator, it's going to give me some gross decimal. Don't want that. So I'm just going to leave it as square root of 5, not square root of 15. Square root of 5. Now, there's one extra thing that we have to do to make sure we're all simplified. As I see there's a multiply in front of that radical sign. 3 times 5 is 15 square root of 5. And now that is my final answer. Now try one question on your own. So, example 2, we're going to be doing the same idea, but we just have a couple extra things going on in this underneath the radical sign. So again, using our math facts, knowing that the square root and squaring a number are opposites and they're going to cancel each other out, my goal is to rewrite each base to have an exponent of 2, if at all possible, so that I can use this rule. So even before I break apart the radical, what I'm going to do is I'm going to break apart everything to have a power of 2. So this first one, 3 to the power of 2, it already has a power of 2. So I'm just going to leave it. The 6, though, I see it has a power of 4. So how do I make powers of 2? Well, I need 6 to the second power to take 2 of those powers. And I have 2 left over, so I need another 6 to the power of 2. So total between these two, I have 6 to the 4th power. I'm just writing them to have the exponent of 2. Same idea with the 11. I want 11 to have the power of 2, but I see that there's 3 up there, so this time I know I only have one 11 left to make those equal to 11 to the 3rd power. And same thing with my 2s. I have 7 total 2s, but I have to write them with powers of 2. So I'm going to do that. Here I have 2, 4, 6 powers of 2, and then I have 1 left over to get up here to 7. So it looks kind of gross. But again, using what we know, that awesome math fact we talked about, if I'm going to give each one of these their own symbol, square root of 3 squared, what's that going to be? That's going to cross out, and I'm going to be left with a 3. We could do it again with the 6 squared. Those are going to cross out, and I'm going to be left with the 6. There's a multiply in between these two. Same thing with the next one. I'm not going to continually write out the radical sign for each one of them, but just know that's what I'm doing here. Those are going to cross out. I'm going to be left with a 6. These are going to cross out, left with an 11. This one, I can't cross out the exponent of 2 because I don't have an exponent of 2. So I have to leave this as square root of 11. Here has an exponent of 2, so those are going to cancel out, left with a 2. Same thing, same thing. Oh, this 2 doesn't have the exponent of 2, so that means it can't cancel out. So I'm going to take the square root of 2. Well, oh my gosh, that looks really scary and gross. Here's what that's going to look like as we go forward and simplify. So all of these coefficients out in front of the radical sign, all of these and these are going to have to be multiplied together. So when I take 3 times 6 times 6 times 11 times 2 times 2 times 2, I get 9,504. Then what's left is a square root of 11 and a square root of 2. Now there is a little bit more that we can do to simplify, and that is from the last video again. If I'm multiplying with 2 different numbers underneath the radical, I can multiply the numbers in the radical and I would get 22. So my final answer should be 9,504 square root of 11 times 2, which is 22. Try one that's much harder like this on your own. Alright, last example for today on this video. Simplify 5 times the square root of 75, a squared, b to the 3rd, c. So this time I see I have variables in there and just all sorts of crazy stuff happening. So let's just kind of break it down using that exact same property that we talked about before. I know that if I have 1, 2, 3, 4 different things underneath the radical, I can rewrite them and give them each their own radical sign. And even though there's variables underneath there, that property works in the exact same way. I know that if I see a square root and a squared like I do here, that those are going to cancel out, and I'm just left with an A. Just like in the last couple examples, if I have a 3rd power underneath here, I can rewrite that as 2 b's here and 1 b here to make 3, so that I can get those to cancel out and be left with a b. Square root of b, though, I can't simplify. There's no squared on that b. Same thing with the c. There's no squared on the c, so it has to just come down. Now, what is the square root of 75? If I go to my calculator, I can type it in and I get a decimal, and that's no good. We don't want a decimal. So we're going to now look to break down the square root of 75. Like from 2 videos ago, we're going to be simplifying radicals. find a perfect square within 75. Well, if I search for a little bit, I can find that the perfect square 25 is in that 75. And it would be 25 and 3 that are going to multiply to make 75. 5 is going to hang out in front. All this stuff is going to hang out at the back. Square root of 25 is 5. Square root of 3 stays there. 5 comes down. A, B, square root of B, square root of C is going to come down here too. Now I can start simplifying. 5 times 5 is 25, and the A and the B can all be written out in front. Then everything else, I have square root of 3, square root of B, square root of C, and again we know if we're multiplying with radicals, the things on the inside we can multiply together to make 3, B, C. We're just going to let them share the radical symbol instead of breaking it apart into their own this time, so we're just going that opposite way. So my final answer is 25AB times the square root of 3BC. Okay, let us know if you have any questions. Try this one first, and then get going on your assignment.